Lesson 3.9, Scatter Plots from Data. Okay, so first we want to talk about what is a scatter plot. A scatter plot is a graph of points that shows a relationship between two sets of data. And it can show if there is a relationship, so correlation, or if there's no relationship, so there's no correlation. So we can have a positive correlation in which the dots move upward in a positive slope, like this. We can have a negative correlation where the dots move downwards. And you can have no correlation where you just get a random mass of dots. So what that means is a positive correlation occurs when both sets of data increase together. So as a child ages, they grow taller. A negative correlation occurs when one set of data increases while the other decreases, and vice versa. So as the temperature increases, the amount of water in a puddle will decrease due to evaporation. And no correlation occurs when the sets of data have nothing or have no effect on one another. So as the number of books that is written increases, there's no effect on the number of fish in the sea. So correlations can be strong or weak. A strong correlation indicates a strong relationships between the sets of data, and a weak correlation shows a weak relationship. A stronger correlation indicates it's more likely that one of the sets of data is directly affecting the other. So we have a strong correlation and a weak correlation. If we look at these sets of data, we can see that the points are close together in the strong correlation. And while we can tell that there's an upward motion here, it's not like a completely random set of dots, but they're still really spread out, so it's a weak correlation. We can also have a strong negative correlation and a weak negative correlation. Then we have something called a line of fit. And the line of fit is a straight line that best mirrors the patterns of the data. So for example, if we have this positive correlation, you can see it doesn't make a straight line, but we could plot a straight line through it that matches the shape of the data. You can see it crosses through some points, and then we have a pretty even number of points above and below the line. Here we have a negative correlation, and this would be the line that would fit this data. Again, it mirrors the pattern, and we have about the same number of lines on top and bottom. And then if we have no correlation, we have no line of fit. Okay, so first we want to identify strong and weak, positive and negative, or no correlation. So I have some examples. In my first example, if I look at the dots, I can see that they're moving upward, so it's positive. And they're not very well clustered, so I'm going to call this a weak positive. Here I can see that the dots are moving downward, and again, they're not very well clustered, so I'm going to call this a weak negative. This is a downward motion, and they're a little bit closer together, so I'm going to go ahead and call this a strong negative. And this over here is called an outlier. It's a set of data that doesn't really fit with the other data. Here I have a random cluster, so we have no correlation. And then here I have a very strong negative. And here I have a very strong positive. Now example 3, I called it a strong negative, but really it would kind of be more like a medium negative. It's a matter of opinion really as to whether it would be strong or weak. Okay, so we can use data to make a scatter plot. Okay, so I have fat in grams on my x-axis and calories on my y-axis. Fish stick have 3 grams of fat and 50 calories. So 3 is going to be halfway between 2 and 4, and I have 50. Here I have 9 and 190. 9 is halfway between 9 and 10, and 190 is just under 200. 7 and 170. 7 is here. 170 is probably right about here. 10 and 185. Here's 10. 185 is closer to 200. 7 and 165, so we're back at 7 and 165, I guess, kind of 2 points almost on top of each other. And then I have 19 and 245. So 19 is here, and 245 is right at the base of the 250 line. Now, it doesn't seem very scattered, but you can also see that it's not in a straight line, and that's what makes it a scatter plot. Here we're going to make a scatter plot and then describe the correlation. So I have the number of stories across the bottom and the height in meters. Now the number of stories is not labeled, so I need to look. My smallest number is 55 and my largest number is 110. So if I made this line 110, I have 1, 2, 3, 4, 5, 6, 7 lines. If this line was 50, and I went up by 10s, it'd be 60, 70, 80, 90, 100, 110. So I'll make each of these 10 stories. The Sears Tower is 110 stories and it's 442 meters. Halfway between 400 and 500 would be 450, so I'm going to be below halfway. I have 102 stories and 381 meters. 102 is probably about here. So I've got 350, so I'm just going to say 381 is about there. I have 55 and 312. 55 is halfway. 312 is right above 300. 75 and 310. 57 and 290. 76 and 287. 72 and 281, 60 and 265. Now describing the correlation, I'm kind of going down and then up and then down and then up again, so I'm going to say there's no correlation. I don't have a specific pattern going upwards or downwards. I'm sort of all over the place. For our next example, we're going to make the scatter plot, we're going to draw a line of fit, and then we're going to use the data to predict the percentage of American homeowners in 1955. So we have this piece of graph paper, and we have the years. We're going to put that across the bottom. So I have 1950, I'll say 60, 70, 80, and 90. And then I have percentages, and I start at 55 and I go up to 65. So if I make these each one, 56, 57, 58, 59, 60, and then 61, 62, 63, 64, and 65. I can get a bit of a more accurate graph that way. So in 1950 we had exactly 55%. In 1960 we had 61.9. So here's 60, here's 61. 61.9 is right under 1960, or right under 62. In 1970 we had 62.9. In 1980 we had 64.4, so that's almost halfway. And then in 1990 we had 64.2, so it went down just a little. Now our best line of fit, we have a pattern, and if we look at this, if we were to actually connect the dots, we would have this kind of weird curve. We can't do anything with a weird curve. We need a straight line to make predictions. So if we look at the pattern and we make a straight line, and it's going to be hard for me to draw a straight line, but if I make a straight line, I'm going to come up through here. Now, I'm not exactly perfectly weighted between the 2 points, but I've got some equal distance sort of happening, and I wish my line was straighter. Hold on. It's not perfect, but it is a little bit straighter. And we can make a prediction about 1955. Now, if I look at 1955 is right here, I'm in this zone. I'm at 51, 52, 53%. No, sorry, 55, 56, 57%. So my prediction would be 57% of people in 1955 owned homes. Now, this is not going to be the same line that somebody else might draw. A line of fit is a matter of perception. I think this line best fits the pattern of the data, but somebody else may make a line a little bit steeper or a little bit flatter. But it would still be close. Okay, now we're going to use another set of data to create another graph, another scatter plot, and we're going to use rainfall in millimeters, and then we're going to estimate in the year 2015. Now, in our last example, we made a prediction of something that was occurring within the data. For this example, we're going to be making a prediction for a year that occurs outside of the data, and this is going to be requiring a little bit more work. So first we have to split up the years, and then we can do the inches of rainfall. Our graph area is a 24 by 24 grid. So I have a 10-year spread. If I make each 2 spaces 1 year, so I can do 90, 91, 92, 93, 4, 5, 6, 7, 8, 99, and then 2000, I can get a nice spread on my data. And then I have 24 spots going up, and I have between 12 and 42 for my millimeters of rainfall. So if I make each space 2 inches, I can spread my data out that way. So if I start with 12, this will be 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, like that. So in 1990, I had 18 inches, so 12, 14, 16, 18. In 1991, I had 21 inches, so that's exactly halfway between 20 and 22. In 1992, I had 28. In 1990, oh, whoops, what did I get wrong? 91 was 21. Oh, I have no data for 92. There's where I made my mistake. Hold on one second, let me erase that. Do be careful of that. Those mistakes do happen. And it was 1993 that we have 28 inches. 94 we have 31. 95 we have 33, so I'm 33 here. 96 I have 37, so 32, 34, 36, 37. 1997 I come back down to 12. 1998 I have no data. 99 I'm up to 40. And 2000 I'm at 42. Now this data here is called an outlier. Actually, okay, this is a set of data that doesn't really match with the pattern, so we kind of have to ignore it. And we have to draw our line of fit through this data. Now we have a really strong correlation, and this almost looks like it's a straight line. But then we have this data here that kind of skews that, so we can't ignore these points here. We have to make a line of fit that goes with all of our data except for our outline. So I'm going to draw this line, and I'm going to draw it to where it pretty much follows all of our data, but takes into account that this shift is occurring. And I actually probably could have made it a little bit steeper than that, but I think that overall this line is indicating the pattern pretty well. Okay, so we need to find the missing data. That would be our data for 92 and 98. And then we also need to estimate the amount of rainfall in the year 2015. So what I'm going to do is I'm going to look at my line. I'm going to find two perfect points. So as I look across the line, I have a point here and here. And I'm going to use these points to find the equation of my line of fit. So this point is 92.5 and 24. And this point is 94.28. And let's see if I can go here. I'll have 96.32, which is actually probably going to be a better point. So I'll use that one, 96.32 instead of the 92.5. And so my first step is going to be to find slope. So if we recall, m is y2 minus y1 over x2 minus x1. So my y2 is 32 minus 28 over 96 minus 94. 32 minus 28 is 4 over 2, so my slope is 2. Then I need to find the equation. So I'm going to plug this in using y equals mx plus b. And I'm going to just use the point 94.28 because it's smaller. And I'm going to get 28 is equal to 2 times 94 plus b. So 28 is equal to 188 plus b. If I subtract 188 from both sides, I have 28 minus 188, and that gives me that b is negative 160. Now this would occur if we went back to the year 0. So you can see we have a y-intercept here, but this is not an accurate y-intercept because this is not year 0. The y-intercept occurs at year 0. This would be 1989. So don't use the y-intercept unless you are actually at 0. So our equation of our line is y is equal to 2x minus 160. Now granted, I realize there was not negative rainfall in the year 0, but this is just our equation of our line. So to find the missing data, we have two ways to approach that. We can actually go up to the year 92 and make an estimate about the number of inches of rainfall, and to go up the year 98. This is the easiest way. Or we can plug in 92 and 98 into our formula and calculate the inches that way. I'm going to go ahead and just use the points on the line. Okay, so 1992 will come up, and we're right here, and I'm going to say that that's 23 inches. So 1992, or sorry, 22 millimeters. And then for 1998, I'm going to come up, and we're here, and that's halfway between 38 and 40. So in 1998, I'm going to estimate that there were 39 millimeters. Okay, so we found the missing data, but to estimate the amount of rainfall in 2015, I can't find that on the graph. I'm going to actually have to plug in a year. Now, if we started with 90, 2000 would be the same thing as 100 on this scale. So 2015 is going to be 115, and that's what we're going to plug in for our year. Okay, so now that we know we're going to plug in 115, I'm going to plug that in. Y is equal to 2 times 115 minus 160. 115 times 2 is 230 minus 160. And if I subtract 160 from 230, I get 70 millimeters. So in the year 2015, from our estimation, we should have 70 millimeters of rain.